Hello, ladies and gentlemen. Today we're going to be doing one of the examination questions from the Mechanics of Materials exam for May 2012. And the reason I picked this question in particular is because I thought it was one of the more easier questions that were available in the examinations. And since all questions in the exam are worth the same, they're all 20 marks each, it would make sense that you would start with the easiest one first and get as many marks as you possibly can. So I think this question employs some pretty basic concepts. So if you studied mechanics of materials or even statics in college or university, this question should be no problem. So the question says that we have an L-shaped bracket A, B, C, D, and E, and it is supported by a pin. As you can see over here, there's a 200 kilonewton force applied at 20 degrees from the vertical, and we have two cables connected by pins at points D and E. They also tell us a couple more pieces of information. They tell us that the diameter of the cables is 16 millimeters and the yield strength is 800 megapascals. The elastic modulus is 200 gigapascals, and the rigid link is designed to resist an inclined load. Yeah, that's the 200 kilonewton applied load. So for the first part, worth 12 marks, they want you to find the forces developed in each one of the cables. So the way we're gonna do this is, so what they want to know is what the force in cable D is, so, or the cable that's connected to point D, and what the cable connected to point C is. So the first thing we're gonna have to do here is to draw our free body diagram, because that's gonna include all our forces, and then once we get the free body diagram, we can go ahead and write our static equations and try to figure out what the force in cable D and C are. Alright, so as you can see over here, I've drawn a free body diagram of the bracket over here, and I've labeled the points D, C, B, and point A over here. So I've drawn a force, or the force in cable D, and as you can see over here that the arrow points away from point D because the cable is in tension, and the same happens for cable C. And there are two reaction forces, one I called Bx, the other I called By. These are reaction forces that are happening at the pin, at pin B specifically, and we have the 200 kilonewton force at 20-degree angle. So what I want to know, or what I want to find out in this question, is what FD is and FC is. Now, I don't really care for BX or BY as of now, because that's not what the question is asking me. So my best option, I think, is to start with the moment equation now, because this is a static structure. We know that the sum of all the forces and all moments is equivalent to 0. So I'm going to use that to my advantage to be able to figure out FD and FC. So the first thing we're going to have to do is figure out what our sense is going to be for the moment, and that is simply the direction that we take or consider to be positive for my moment. So we're going to take the counterclockwise direction to be our positive sense for the moment. So, and now the second thing we have to figure out is where exactly are we going to take the moment, about which point are we going to take the moment. We could take it about point A, point B, C, or D. And our best option over here is to take it about point B, simply because if you take it about point B, that automatically eliminates the need of you to write down the reaction forces Bx and By. And secondly, you don't want to eliminate FC and FD. You want to have them in your equation so you can be able to figure out what they are. So we're going to take the moment about point B. So we're going to write M sub B is equal to 0. So we know that the sum of the moment in this structure everywhere is equivalent to 0. So the first force that we're going to take into consideration is our 200 kilonewton force over here. Now, just a quick reminder that the formula for moment is equal to the force multiplied by the perpendicular distance. That is, if we, for example, have force, we call that F, and we have some point, let's call that X, and we want to know what the moment that the force F applies to point X. All we have to do is, if we are given the distance D, and you can see over here that the force is perpendicular to the distance, we can easily find out what the moment about point X is simply by multiplying the force vector by the distance between them. So in this case, we're going to use the 200 kilonewton force over here. So we're going to need the perpendicular component of that force vector, and the perpendicular component would be along the green reference line that I drew over here. So since that 20-degree angle is over here, so that would be the adjacent side, so that would be the cosine. So we would take the cosine of that 20 degrees, so we would say 200, we would say 200 kilonewtons multiplied by the cosine of 20 degrees. So that's my force part. Now the next part is my distance, so I need to know the distance between point A and point B, and it's given over here as 500 millimeters. I'm gonna need to convert that into meters, and it is going to be 0.5 meters. Now you will also notice that I put this to be positive because once I apply the 200 Newton force over here, it is going to rotate in that direction, which according to our sense is the positive direction, so it's going to create positive moment over here. The next two forces that I'm going to consider are going to be FC and FD. And of course, FC is going to create rotation in that direction. So it's going to be opposite to what we picked to be positive. So our moment is going to be negative. So force FC is going to create a negative moment. So we're going to put negative and then FC multiplied by 0.4. The distance between point C and point B is given over here, and it is 0.4 meters. And of course FD has the same direction as FC, so it too will create a negative moment. So we're going to say FD multiplied by the distance between FD and between point D and point B is 1 meter. 1 meter. And that pretty much covers everything. So we've considered FD, FC, and the 200 kilonewton force. Of course, we don't have to consider BX and BY because the very fact that we picked point B to be the point of which we take the moment, so that means we don't have to worry about BX and we don't have to worry about BY. So we know that the sum of all of these three moments is equal to 0, and that will be our first equation. So I know this is a good equation because it has FC and it has FD, which is the two unknowns that I want to figure out. Now all I'm going to need to do is come up with at least one more equation. Because we have two unknowns, we need two equations to solve for this system. So we should be looking for another equation that has also FC and FD. So let's try and sum the forces in the X direction, see if that helps us. So once again, because this is a static structure, we know that the sum of all the forces in the X direction is going to add up to 0. So I'm going to look at my free body diagram over here, and I see that FD is in the X direction because it goes along the horizontal, and so does FC, BX as well. And there is another component of force of the 200 kilonewton force, and it is going in that direction, so that would be the negative X direction over here. So I'm gonna go ahead and start writing these. So FD is going to the right, so that's positive, so I'm gonna say FD plus FC plus BX minus, because the component, the horizontal component of the 200 kilonewton force is going to the left, so that makes it minus 200 kilonewtons multiplied by the sine 20 degrees. Now we have to use sine because if that side over here along that line which we used before was the cosine, so that would mean that this side is the sine side. And these are all the forces that we have acting in the x direction, and they equal to 0. Now this equation would have been perfect if we didn't have bx over here, because we could have just used this one and that one to figure out FD and FC. So this one is not much use, is not that useful to us right now. So let's see if maybe the force in the y direction is going to help us any. So we're going to assume that upward is positive, and we actually only have two forces going in the y direction, and that is By as well as the vertical component of the 200 kilonewton force. So since By is going downwards, we're going to make that negative, and also the vertical component of the 200 kilonewton force is going downwards as well. So we're going to write minus 200 kilonewtons cosine 20 degrees. Now this equation only helps us get By, so it won't really help with the moment equation over here, because we still don't have enough information to figure out what FC and FD is. So looking at this diagram, the next trick that we could possibly use would be similar triangles. And the way this works is because I know there is a fixed distance between point D and point B, as well as point C and point B. So I'm going to show you in a second that there's actually a relationship. There's some sort of a ratio between point D and B and C and B that we can use to figure out the displacement of how far point D is going to move and point C is going to move, because once we actually apply the 200 kilonewton force as seen here in the diagram, this whole bracket is actually just going to move just a little bit in the counterclockwise direction. Okay, so as you can see over here, what I've drawn is the bracket after the force has been applied. So the initial position of the bracket would be along this line right here, and so originally point D would have been right here, point C would have been right here, but now point C is here and point D is here.